Can you hear me? Thanks.
Yeah, can you hear me now? Okay. So let's begin the things. So we are in the partial differential equations course, lecture number 9. Okay. So also we are in the chapter number 3 of second order equations. In the last lecture we have seen how to solve a homogeneous equations. Okay. So let's do some revision and we can use some of this. Okay. So why less number of people? 42. Okay. So as I said to you, the homogeneous PDE with constant coefficient can be we can written as A naught with the coefficient A naught up to AN. Okay. So first we have solved for the nth order for the general idea. Okay. Then A1 da bar nz over da bar x n minus 1 of da bar y times, and then it goes up to an da bar nz over da bar y to the power n can be a function fx comma y. Okay. So in this case, which is a linear equation and homogeneous, which indicate each terms are, in the nth derivative. If it is second derivative, you have to check whether all the terms are in the same orders. Okay. Then the solution will be in the form of complete solutions. Complete solutions can be taken as which is equal to complementary factor plus particular integral. So we are solving in a two different ways, and then we add both to get our complete solutions. Okay. So we have seen some rules to solve this. First of all, we have to identify whether it is a homogeneous and constant coefficient linear PDE. Then we have to make next steps to make it into the symbolic form. Where for the symbolic form, so we use d for the da bar over da bar x terms and d dash for da bar over da bar y terms. So this entire equation number 1 can be reduced to the form of d comma d dash, which is equal to any function in this side. Okay. Then the next steps we symbolic form, and next we use the auxiliary equations. Auxiliary in the sense we take d is equal to m and d dash equal to 1, and I also gave you some note where we can use in the alternative way also. So then again the equation will be turned into for this equation, for the d part we have 1 and d dash 1, which is equal to, again for the auxiliary part we are considering only this LHS part. Then we solve this one and to get m is equal to 1. Okay. So when you are equating to 0, we can find the m values. Then we can write the complementary functions for this equation. And then we have to use, there are some three cases we have used: case 1, case 2, case 3 to write our complementary functions. Whether the roots can be distinct, and then root can be repeated roots, or maybe the complex. Okay. yeah, two repeaters and all repeaters, as well as the case of complex also. Okay. And in the particular integral case, we use the form of which is equal to 1 over whatever we are finding here, f of d comma d dash times of the RHS, any given RHS of function of fx comma y. So this is a small f. And then according to the RHS, we have a different form of solving methods to this part. Okay. So hope you have gone through these things, and so I'm not yet finished typing, so I'm not yet send the things, but hope you get some notes. Okay, so let's just for the revision, let's do one or two question, and then we can go to the next sections. Okay, so here I think we have done some questions. Yeah. Okay. I think what about this one? Can you do this exercise? Okay, let me try this one. D squared minus 4. So they didn't give you the equation, but they have given you the some after some steps. Okay, so sometimes they may give you the question in this ways. Okay, so you don't need to find this. I mean, simply symbolic forms. They already given you with the symbolic forms. Can you solve this one? So we in these questions, first step and second step already done. So you don't need to consider whether it is homogeneous or finding the symbolic form. So they have already derived that. Only thing is you have to go from the next steps. It means find the auxiliary equations and the next steps. Okay. So can you start working? So first of all, in the auxiliary equation, we have to transform the d as m as well as d dash as 1. Okay, so if you take this part of f d comma d dash, we will have m squared minus 4 is equal to 0, isn't it? So this will be easy task for us. So what will be the m? Can you answer me? The roots of m. So these are school kind of things, so I don't need to deal these. Can you answer me quickly so we can continue? In this class, I will note who are answering me. Okay, so that's what I'm taking. I'm gonna take that as today's attendance. Okay, so whoever answer only the people I'm taking as the people of here. Okay, there are okay. Just marking your attendance. Can you answer me at least for these questions? 145, 77 is here. Okay, 142, 03, 033, 93, 005, 056. At least for this question, everyone have to answer me. Whoever here should answer me. Otherwise, I will take as absentees. Only 20 people have answered. What about others? Are you available? There are 47 people here. Four, 6, 8, 10, 12. 30. Now only 30 people. I'm still waiting for your answers. Everyone answers for the attendance purpose. This is not a big question for me to wait, but yeah, the others, please continue your answers so I can join you. So 35. Is that 35? Shall I close my attendance taking? Is there any more to answer? Only 35 have answered. So I'm not gonna wait anymore. Okay, so what's the answer? As you said, it's a 2 and minus 2, isn't it? So it can be written as m minus I mean, m squared minus 2 squared is equal to 0. So m plus 2 is equal to 0. It's an a minus b, a plus b. So in that sense, so yeah, therefore our okay, now the complementary functions can be written as I said, you can use yeah, pi f or anything, okay? Pi 1. So you have to add y plus mx, isn't it? Y plus 2x plus, so sorry, yeah, so pi 2 y minus 2x, okay? After that, after you taking pi and pi 2, you have to mention what it is, okay? Pi 1 and pi 2 are arbitrary functions, something you have to write down, okay? Okay, so I hope you have written the complementary functions. So let's go back to the particular integral. So that's what because of this is okay for us, isn't it? So because of this RHS, we may have some different answers according to this RHS part. So can you try yourself sometimes? So now particular integral, we can say that will be f of t comma d dash times RHS. So we already have the symbolic form, so we can use it, times of cos 4x cos give me a second. Yeah, cos 4x and cos 3y. So in here, this is about your A-level knowledges. So what do you think? Cos 4x cos 3y. So have you found that one? In which way it is? I think, yeah. I'm sorry, I didn't send you the notes anyway, but I'll give you here, okay? So we have one, the formula to finding the PI cases, okay? So it says, so using that, okay? Using the formula for the case, okay? It says if you are having something, okay, function of d squared comma d dash squared of cos ax cos by, okay? In that sense, your particular integral can be 1 over f of, where you have to use, d squared is equal to, okay, minus a squared, okay? Similarly, d dash squared is, so you have to be careful in see, this is belongs to d squared, d dash squared, okay? So d dash squares can be, yeah, give me a second, b squared, okay? So, yeah, so you can substitute this one, minus a square minus b squared times for the cos ax cos by, the same, okay? So what you do is, whatever this, the eighth coefficient, the bth coefficient, see here, we have a here, for the, we can see that later, okay? This is the notes, this idea, okay? So you have to use whatever the coefficient of, if it is cos ax cos by comes, okay, you have to transform the d squared. So here also you have to check. So some the question will come on that same way. You can check d squared comes, okay, cos ax cos by. So for the d squared, you have to transform this one a, this coefficient squared with minus, okay, negative. Similarly, whatever the d dash squared, you have to transform it as this coefficient, okay? So since these two are, you can write cos 3y, sorry, you can write this way, isn't it? Ax by. So wherever the coefficient of x, you have to take as a, coefficient of y as a b, okay? So this is minus b squared and minus a squared for the d squared and d squared. So this is the idea, okay? So here you can put cos A, cos BY. So that is, this is our particular integral for this case. Okay, I will give you all the cases after this. Okay, so using this, also if f of minus a squared minus b squared not equal to 0. So this is also one of the conditions. Okay, can you use this knowledge, make it yeah. Same also for the sin x, sin ax, sin by. Okay, only thing is you have to transform whatever the sin ax, a as a d squared term, b as a, so you can write that one also. Okay, so 1 over f d square d dash square. Okay, write this as a note. Okay, and sin ax, sin by, the same thing. Okay, same whatever this one. Okay, you can write like this, 1 over okay, I'll write that one that side anyway, f of minus a squared minus b squared times sin ax sin by. Okay, so only thing is you have to take the ax coefficient for here d squared, y coefficient as b squared, same thing, but according to cos and e, you have to put here cos a cos by. For this case of sin x sin y, you have to put here RHS as it is. Okay, so can you take the can you find the pi according to this? It's not a big thing, isn't it? Just to transform. So here d squared will be, what is the d squared? Minus, okay, first of all here 4, okay, minus 4 squared, so it will be minus 16, isn't it? So similarly d dash squared will be minus b squared, here b will be 3, so minus 9, isn't it? Okay, can you write down this note so I can continue? Okay, let me continue. Okay, so our pi uh, 77, can you check your answers? Yeah, so you didn't use this idea, isn't it? So you use this idea and find the answers. So pi in the case, okay, actually that I have given for f d square d dash square. So actually what is our f of d square d dash square in this question? We have d square minus 4d dash squared of z, no? So you don't need to consider z. So only thing is this one. Okay. So according to this function, you have to transform our examples question. Example. Okay. Time of RHS cos 4x cos 3y. 3y. Okay. So we know A is equal to 4, B is equal to 3. Just write down in the same way what I am writing. Okay. So in the exam also, these things will get some marks even though your answers are wrong. Your steps, as I said to you earlier also, your steps will get some marks. So try to get some marks using these steps. Okay. So we have d squared will be minus a squared. So minus 4 squared. This will be minus 16. Okay. So be careful, put the minus. Okay. Don't take like this. D squared is equal to minus, 4 whole thing squared will be plus. Okay. Don't use. You have to take only the a squared and the negative comes before that. Okay. Similarly, d dash squared will be minus 3 squared. This will be minus 9. Okay. So you just transform whatever here. So this will be minus 16 minus 4 times d dash squared will be minus 9. Okay. Times cos 4x cos 3y. Okay. Okay. Which is equal to what? Can you try? This will be plus, no? So 9 times 4 will be 36. 36 minus 120, isn't it? That's all. We have found our pi. It's not a big thing. Only thing is you have to remember these steps. Okay. So I'll try to give you that thing so you can memorize. Okay. So we are not finished yet our complete one. We just found our integral terms. I mean particular integral. Okay. So this is our particular integral. So already we have found our complementary function. So is that correct? Please let me know. So plus 36 minus 16 will be 20, no? I hope. Okay. Let me continue the complete solution. Therefore, the complete integral or complete solution. Okay, integral of the given. So you don't need to write this much, but anyway, you have to write something. Okay. So that is equal to, that is what we are solving for. So already we have find CF plus PI, no? So it just substitutes. CF we have found complete integral will be CF we have found pi 1 y plus 2x plus pi 2 we have seen pi minus 2x. Again, we already found this will be 1 over 20 cos 4x cos 3y. So already our meeting gonna finish 10 minutes. Okay. That's all our complete equations. Hope you understand this one. Okay. So just give a space for this question so you can try something. Yeah. So second one, try this question. Okay. D square plus d dash of z is equal to cos 2x cos y. Same idea. Okay. Third one, you can try. No need to try now. You can do as a homework. Okay. D dash plus d squared that is equal to sin x cos y. Okay, this is something interesting. So let's try this one. Okay. First of all, write down the question. So I will give you the idea for this one. So actually, what is this one? This one you can use your idea. I think 77 already used that idea. Okay, what is that? Because we have the rules for cos x cos by or sin x sin by. So we don't have for anything for sin x cos y or cos x sin y. Okay. So there we have to use our trigonometry identity. Okay. I will give that as a note. Okay. So just write down the question. I will give you the note for the particular integral. Okay. Complementary, we have covered everything. Only thing is I need to give you the different PIs. Okay. Okay, let me give you the ideas of PIs. Okay, as a rough ideas. Okay. So PI, I already have given you some, isn't it? I think I gave you, give me a second. I think I gave you the idea for what if it is RHS equal to 0. Okay, go back and see. So what if RHS equal to 0? Okay, you go back and check. What e to the power ax plus by? Okay, I think I already give you this idea also. So I don't need to spend time with this. Sine ax plus by or cos ax plus by, both having, you need to put what is, d is equal to minus a square, d dash, d squared is equal to minus a square, d dash squared will be minus b squared. Again, d times d dash comes, you have to transform minus ab. So you know how to find the ab. Okay. So only thing is you have to make the integral what do you call trigonometry identity. So trigonometry identity in the sense for these questions. Okay. Sine, give me a second. For example, sin x. Okay, sin x cos y. So how you can write this one in terms of sin ax by, that knowledge? What you can use? Can you write down? What is sin a plus b? I forgot about this. So Can you answer me for what is sine A plus B? What is sine A minus B? Okay. Then if you add sine A plus B plus sine A minus B, these are trigonometric no A level things. So what you'll get? Okay. Similarly, sine A plus B minus sine A minus B, what you'll get? Similar way, you can construct for cos A plus B, cos A minus B. So if you are having something, different cases, you have to use this identity. So what if it is cos A plus B plus cos A minus B? Or what about minus? Okay. So can you tell me what is sine AB, A plus B? Yes. So sine A cos B. I'm just waiting for your answers. Cos A sine B, isn't it? So what about minus? Same one, minus, no? I hope, yeah. Sine A cos B minus cos A sine B. So what the case of adding these two? So plus and minus, these term will be vanished. So it will be 2 times sine A cos B, isn't it? So when you need this process for this equation, example, you have to divide this by 2, isn't it? So that's the idea you have to use here. Then you can use this A as a x coefficient, B as a y coefficient. Okay. Similarly, what about cos A plus B? Okay, cos A cos B minus, no, first of all. Yeah, sin A sin B. And then this one is a plus, no? Cos A cos B. Is that correct? Sin A sin B. Okay, so if you are adding both, you will have these terms will be vanished, or 2 times cos A cos B. So I think, yeah, is that you are getting the same answer if you use for our cos A cos B? Okay, I think in the rules of PI, they have given, yeah, what is the case for cos AX cos BY, sin AX sin BY separately. But the thing is same, isn't it? So I think the 77 has done this question. Can you recheck our example? So you have put something. So did you get 1 over 20? If you're substituting this idea. Okay, I don't know. You just check, okay, again, as a homework. For the last question we have done, can you use this one and use this the same thing, no? For example, here for the, sin AX, sin BY, as well as cos AX, cos BY cases, when RHS are these, okay? Cos AX, we have D squared will be minus A squared, D dash squared also minus B squared. But in the case of sin AX plus BY, okay, I think in that case, you may have not only D squared, D dash squared, you also have D into D dash. Okay, in that situation, you use D squared will be minus A squared. These two are same. Okay, only thing is for this case, D into D dash will be minus AB. Okay, but in our question, earlier question of, what is our questions? Cos AX, cos B case, we don't have D dash, D into D dash, no? So in this, you can, I think you have to put 0, I guess. Okay, so you have to use this one. If you have only D squared and D dash squared, use this. Okay, if you are having extra D into D dash or coefficient, terms in the in the equations, you have to use these three, okay, for both ax plus by, okay. Check yourself these questions again, whether these are applicable on if you try that way also, okay. Okay, hope you get some ideas regarding, because yeah, this is 1/40, but we have 1/20 now. So you are having two terms. One is a is 4, b is 3. Other one is a is equal to 4, b is equal to -3 now. So did you try that one? In both cases it will be same, no? Okay, so if you are getting a different answer, you have to omit. Okay, so anyhow you have to memorize it. So in this complementary function and PI is a big deal to deal with, but hope if you do some practices, it will be easy for you. Okay.